Let us learn how to simulate and synthesize a Verilog code using Modelsim and Xilinx respectively. First we shall look into Modelsim. Let us open Modelsim. Let us create a new project. Specify the desired name and directory. Now let us create a new Verilog file. Click on Create New File and give a proper name satisfying the rules. Select the file type as Verilog and then press OK. Double-click on the file to open an editor window. Here we can type in the code. In the same way, a testbench file is also created in order to test the functionality of the code. I have considered the design of a comparator, and I will add the already created design file and the testbench. Now we have to compile both the files. Go to Compile and select Compile All. The order of the compilation can also be modified here. After successful compilation without any errors, go to Simulate tab and click Start Simulation. Drop down the Work folder and select Stimulus. Note that Stimulus is the module name given to the testbench Verilog code in our design. Add all the signals to the wave window. Then we can run the simulation by clicking Run here, or by typing Run and the desired time interval in the transcript window. We can also add breakpoints and run till the specified line in the code. Let us run the simulation. By looking at the waveform and pointing the cursor on the waveform, the results for different values of A and B can be verified. By this way, a Verilog code can be created and simulated using Modelsim. Now let us concentrate on the synthesis of a Verilog code using Xilinx. First, open the Project Navigator. Click on New Project to create a new project. Enter the name of the project and choose its location and working directory. Next, select the device and its properties depending on the target hardware. Then select the simulator as Modelsim PE Verilog and the preferred language as Verilog. After creating the project, we have to create a Verilog module. Right-click on the project name, then select New Source. Click on the Verilog module, and enter the module name. Defining the input and output variables here is optional. Now, we have to type in the Verilog code here. I am considering the design of a comparator, and I will enter its Verilog code and save. We shall create a testbench in order to verify the functionality of the comparator. Create a new source. But now we have to select Verilog test fixture and specify the name. Select the source with which you want to associate the testbench. After creating the testbench file, we have to enter the stimulus code which instantiates the main code and has different input combinations in order to test the design. We can simulate the code by selecting Simulation here. Then select the testbench and double-click on Simulate Behavioral Model. This will open the Modelsim, and we can verify the results. Now let us synthesize the code. Change to Implementation here. Run the synthesis by right-clicking on Synthesis here. The main purpose of synthesis is to perform logic optimization on the design and generate a gate-level netlist. After the synthesis of the Verilog code, we can implement the design on the hardware by running Implement Design. This will translate, map, and finally do placing and routing depending on the architecture of the target device. Finally, we have to generate a bitstream file containing configuration data for target FPGA device. Design reports are also generated, and it has details of the processes performed. This is how a design can be synthesized and implemented on a hardware device using Xilinx.